So first thing we're going to do, let's kind of back up to what we were doing yesterday before we get into what we're doing today. We're going to do just a quick review just in case, because that's one little thing we'll add to what we did yesterday. So it's a review, and then we're going to kind of build up to what we did yesterday, and then we'll start the brand new thing with matrices, with multiplication here in just a little bit. But let's say that matrix A is -1, 0, -4, -2, and -3, -9. All right, and for B, let's go with 4, -5, 4, -1, and 1, -6. All right, so that's two matrices. All right, first thing we're going to do is going back and making sure everybody's good with it. If we talk about the size of the matrices, again, it's rows by columns, and again, rows is going. It's how many? This would be a row. So 1, 2. There's 3 rows, and columns are how many you've got going up and down. So we've got 1, 2 columns. So both of these matrix A and matrix B would both be a 3x2 matrix. All right, and what we're going to do, we're going to do a couple of things here. Let's find A minus B to start with. Okay, so it's going to be -1 minus 4 for the top left number. Top right-hand number, it's going to be 0 minus -5. And again, for subtraction, if it's minus a negative, it's probably good to go ahead and put that second number in parentheses so that you can see the minus negative, so we'll know to go back and make that one a plus. For the second row, it's -4 minus 4. It's -2 minus -1 on that second column. And then on the bottom row, it's -3 minus 1, and then -9 minus -6. Okay. Now, and again, if you don't necessarily have to write this step out, but a lot of times for people, it's good just to kind of make sure that they keep everything straight. And then just go back and do whatever the numbers say. -1 minus 4 is -5. 0 minus -5 is really 0 plus 5, so that would be a 5. -4 minus 4 is -8. -2 plus 1 would actually be a -1. -3 minus 1 is -4. And then -9 plus 6 would be a -3. Okay, so we talked about addition, we talked about subtraction. Always good to go back and review subtraction because, again, it's not necessarily that it's hard. You just got to remember that it's always everything in here minus everything in here, and you'll have some cases where you'll have a minus negative that you have to kind of go back and fix for those. All right, sticking with those same matrices up here with A and B, let's go ahead and let's find -4A plus 2B, where we do the scalar multiplication. Again, scalar multiplication is where you just take a matrix and you multiply everything by a specific number. In this case, we're going to multiply everything in A by -4. So doing -4 times everything in A, that's going to be 4, 0, 16, 8, 12, and 36. All right, and then taking the B matrix and doubling everything, that's going to be 8, 8, 2, -10, -2, -12. Okay, so this one was all a subtraction doing A minus B. Once we multiply by -4 to get this number, we multiplied everything here by 2 to get these numbers. Now we're just adding them. So adding those two matrices together, it's 4 plus 8 for 12, 0 plus -10, which would just be -10. 16 plus 8 is 24. 8 plus -2 is 6. 12 plus 2 is 14, and then 36 minus 12 would be 24. Okay, And I think that's pretty much kind of where we left off yesterday. That was one of the last things we did was we added in the scalar multiplication so that you can multiply some numbers to kind of get the pieces there. In this case, we're doing a scalar here and a scalar here, and then at the end of it, we're going to come back and add them together. I think we did one yesterday where we did some subtraction in the middle, but whether it's adding or subtracting, we kind of did both of those examples there. All right, now here's where we're going to kind of spin off of what we did yesterday. Still not necessarily multiplication yet, but it's just a spin off of the scalar multiplication we've got here, that we're going to look at solving a matrix equation like we did yesterday. But we're going to solve it with some scalars involved. Okay, I'll go ahead and write it down so we can kind of have it set out here. Okay, so for this equation, again, it's similar to what we did yesterday, but a little bit different from the problem we were doing yesterday. We wanted to kind of just build up to it so that everybody was okay. Hopefully had a little bit of chance to practice with it. So first thing is we've got it set up. You do have a little bit of scalar. Here's the scalar part of it, that we've got the 3x minus 2 times this matrix equals this. If you've got the scalars involved, I would go ahead and multiply out those scalars. Now, in this case, and this is kind of what we were talking about yesterday, the way it's written, it's 3x minus 2 times this one. You can either, think about this as being 3x plus negative 2, that you can multiply everything times negative 2. But in this case, since it's 3x minus, let's just go ahead and multiply everything by 2 here. So we'll go ahead and do the scalar multiplication and just double this matrix that we have here. So doubling everything, that's negative 2, 10, 14, and 0. And the matrix on the right-hand side, we'll just rewrite it because we didn't do anything with it yet. Okay, so just multiplying everything by 2, now we've doubled out this matrix to get it to this point. So now that the scalar multiplication is gone, now it's just a like solving a matrix equation. All right, and we're still going to solve for x. So we're still trying to get x by itself here. And what you got to kind of think about on this one is that if we covered, everything up except for the first number here, you've got 3x basically minus 2 equals 17. And if you think about the problem that we had before, if it was 3x minus this thing equals this number over here, if we were solving this equation where it was 3x minus some number equals a number, that if it's 3x minus this thing, the first thing you would do would add that to both sides. If that was a number, well, even with matrices, you'll still do the same thing. If it's 3x minus this matrix, well, we're going to add this matrix to both sides. Negative 2, 10, 14, and 0. Okay. Now, and again, don't, because sometimes people kind of key in on the numbers. They're like, well, I'm doing negative 2 and I'm doing plus negative 2. Wouldn't that cancel? Remember, it's minus a negative 2. So if you do minus negative 2, that would make that a positive 2. So then that's 2 plus negative 2, which would make that out to be 0. So just realize that it's 3x minus this thing. Think about that as being like a big giant number. You can think about this as being like 3x minus 4 or something like that. That if this is 3x minus 4, we're just going to add this same thing, and that'll cancel all this stuff out here. All right, let me pull this down. All right, so that'll leave the 3x over on the left-hand side. And on the right-hand side, you're just going to add it together. So it's 17 plus negative 2, which is really 17 minus 2, which would be 15. Negative 13 plus 10 would be negative 3. Negative 7 plus 14 would be 7. And then 0 plus 0 would be 0. All right, I'm just going to rewrite these so we can bring them closer together. All right, so just condensing it down so they're not so spread out. We've got 3x is equal to this. And still think about what you would do in a normal situation if you were solving an equation. If it's 3x equals 15, you would just divide both sides by 3, right? This one, you do the same thing. If you divide this side by 3, you've got to divide every single number over here by 3 also. So whatever you do to the left-hand side, you're still going to do the same thing on the right-hand side. Okay, so those will cancel out. We get the x by itself. And then now it's technically, you're multiplying both sides by 1/3 because you do 1/3 of 3. That would cancel. So if they talk about it technically being scalar multiplication, technically we're multiplying by 1/3, but that's the same thing as dividing it by 3. So it's just, a little different way, the way they're saying it there. 15 divided by 3 is 5. 3 divided by 3 is 1. 7/3 won't simplify, so just leave it 7/3. And then 0 divided by 3 would be 0. Okay, so did something similar to that yesterday. Just wanted to kind of build on that one a little bit, that it's still kind of the same thought process that we were doing yesterday, just a little tweaky, a little different from what we were doing yesterday. Okay. All right, so that was kind of just, again, wanted to kind of go back and review what we were doing yesterday, make sure everybody kind of remembered what we were doing. Mostly it was adding and subtracting. A little bit of multiplication where you're just multiplying a matrix by a number. And then from here, it was just adding and subtracting terms. And then again, technically this is still multiplying by a third with scalar multiplication, but we also kind of flip around and say, well, it's kind of like scalar division, and we're going to divide everything by 3. Okay, so that's kind of where we left off yesterday, and kind of added in a couple of bit things. But here's where we actually kind of jump in today. This is where we're actually going to start multiplying matrices. Keeping up with notes, this would be number 14. Again, today's date is April 20th, and today is a Tuesday. Okay, if you start your notes back on the first part when we were doing the review back here, that's fine. But again, just kind of keeping up with where we are. This is multiplying part. All right, very first thing with matrices, the first thing you've got to be able to do is know the size of a matrix, because that's always the contingency on this one. You can't just take two matrices of any size and multiply them together. That there has to be a certain size fitting on these to kind of go with it. So here's kind of what we're doing with these. To be able to multiply matrices, so to multiply matrices together, and do a colon or a comma or whatever. They're just kind of doing a little pause here. The columns of the first matrix must equal the rows of the second matrix. Okay, so that's the very first thing you've got to check, is that you're going to figure out the size of the first matrix, and you're going to figure out the size of the second matrix. And the one thing that has to be the same is the columns in the first matrix has to be the same amount, same size as the rows of the second matrix. So you got to have the same number of columns in the first matrix and the same number of rows in the second matrix. If those two things don't work out, then you cannot multiply these two things together. Okay, so if they are the same, the size of the answer will be the rows of the first matrix and the columns of the second matrix. Okay, so just to give you, before we do anything at all, multiplying these together, let me just kind of give you a visual for this one. Let's say that we've got matrix A, and we look at it and we figure out that it's a 2x4 matrix. And we're going to look at column matrix B, and maybe it's a 4x3 matrix. Okay, and probably one of the questions will be, can you multiply A times B? Okay, and if you write down the size of the matrix, it's a really, really, really easy way to figure this thing out. That matrix A, and again, just underneath these, I always just write down the size of it. It's a 2x4 matrix for matrix A. Matrix B is a 4x3 matrix. And the easy way to know if you can do it or not is basically you just look at the two numbers in the middle. If those two numbers are the same, then yes, you can. Okay. And that's your check. That's the one thing you want to look at on the matrices is that you just write down the size of it. If the two middle two numbers are the same size, then yeah, you can multiply these together. If you multiply this one together, the answer, the size of AB in your answer, well, you're just going to take the number you've got left over here and the number you've got left over here and know that that's going to be a 2x3 matrix. Okay, so if these two numbers in the middle are the same, then whatever numbers you've got left over, that's the size of the matrix that you're going to have left over. That you'll have 2 rows and then 3 columns. Okay, now, and some of the questions may ask you just, one of those things, that may be all they do. They may not actually have you do anything with the matrices. So I know a couple of homework questions, it's going to ask you, okay, can you multiply these two things together? It's going to be just a yes or no type question. So if we flip around on the flip side on this one, let's do this at the bottom because this one won't take a lot of room. Can you multiply B times A? All right, B was a 4x3. A is a 2x4. And if you look at the two middle numbers here, they are not the same. So they ask you, can you do B times A? In that case, no, because they're different. Okay, so that's the very first thing you want to do. That's the simple kind of check that you can do just by the size of it. Just write down the dimensions of the first two matrices that you got to multiply together. Again, if the middle two numbers are the same, you go ahead and multiply together. If the numbers in the middle are different, then you say no. There's nothing you can do with that. Okay, so here's what we're going to do. The rest of the way, what we're going to do is just give you some examples, and then show you the steps on how to actually multiply and get these numbers together. And basically, here's what we're going to do. To do the actual multiplication, you multiply each row of the first matrix by each column of the second matrix. And that's it. To me, that was the hardest part, was remember which one was which. So it's kind of one of those things that going into the test for this one, I remember being in y'all's shoes in high school and going through these. I just had to memorize it. Okay, it's rows times column. It was rows times column. It was rows times column. I just had to kind of get that going in my head. And once I got that one, then everything was okay. But to me, I just had to memorize it. Just had to kind of get it figured out that it's okay. It's always rows times columns. It's RC. If anybody drinks, RC colas or not, but that's just a different version of Coke or Pepsi. So if you remember that one, then it's always RC first. It's an RC order. Or if you're model car collectibles kind of thing, they have RC cars that you can do, radio controlled cars that you can kind of do same thing. So, but anyway, you want to go ahead. So, all right, so let's do this. Let's give you some so you can kind of see exactly what it is we're going to look at. We'll start with just a fairly small matrix on both these. So let's say matrix A is 2, 1 and negative 3, 0. And then for matrix B, let's go with negative 1, 3, 0, and 4. Okay, so very first thing we're going to do is, again, we're always going to do the rows of the first matrix by the columns of the second matrix. So for this one, we start with the first column that's here, which is 2, 1, and we're going to multiply it by the first column here, which would be negative 1, 0. So it's the first row of A times the first column of B. So that was going to be 2, 1 times negative 1, 0. Okay, now here's that whole matchup thing when you did these, because the reason the rows and the columns had to match up is that you've got to take the first number in the first row here, and you're going to multiply it by the first number in the first column here. So it's the first number here times the first number here. So that's 2 times negative 1, and then you're going to add that to the second number here times the second number here. All right, so then doing that is negative 2 plus 0, so that would be negative 2. All right, now, and we didn't do this back here, probably should have. This one was if you look at matrix A, it was a 2 by 2 matrix. If you look at matrix B, it was also a 2 by 2 matrix. So the twos matched up, which meant we could multiply. The size of the answer would then be a 2 by 2 answer for this one. So when we do A times B, if we were going back and doing A times B, the answer back up here is going to be a 2 by 2 matrix. So we put a box over here just so we kind of go back and see what it is we're doing. Since this is the first row in the first column, that's telling you where this answer is going to go. That this negative 2 goes in the first row in the first column. Okay, now, and the way it goes is that you've got to do the first row of A. You've got to do everything you can with it. So since there's still one more column left over here, we're still going to take the first row of A. And you've got, basically, if there's 3 columns, you got to multiply it 3 times. We've only got 2 columns. So we're going to multiply it 2 times. So now we're going to go get the second column of B. Multiply it. All right, I'm going to pull this up so we can see it just a little bit better here. All right, so the first row of A, well, that was 2, 1. Now we're going to the second column, which was at 3, 4. Okay, again, it's first number here times first number here, so that's 2 times 3. And then we're going to add that to second number times second number. So 6 plus 4 is 10. All right, and again, that's the numbers here. When you write it down, that tells you where this thing goes. This is the first row of A, so we're staying in the first row. Now we're in the second column, which means this will be the second number in the first row, so that 10 will be the second number that's in the first row. All right, so backing it real quick. So now we multiply this one. Now we've taken this first row and we multiplied it by this column and this column. There's no more columns, so now the only thing left to do is now we're going to go down to the second column. So once we've gone through the first rows, well, now we go to the second rows. So now it's the second row of A, and now we're going to go back to the first column and then kind of start the process over. So the second row of A was -3, 0, and the first column of B was -1, 0. All right, again, first number here times first number here. So that's -3 times -1. And then we're going to add that 2. Well, the only thing left then is 0 times 0. Okay, and that would be 3 plus 0, which would be 3. All right, again, this is basically telling you the location. Now we're going to the second row of the answer. So now we're down here. This is going to be the first number that we're going to put there. So that 3 will kind of go in the bottom left-hand corner. All right, and then only one more thing to do. Now we're doing the second row of A times the second column of B. Okay, so we stick with the -3, 0. But the second column was at 3, 4. Okay, now again, when you go through these, you don't necessarily have to write down, that's the second row of this and the first column. This is just making sure that we've got all the steps kind of covered. So it's the first number here times the first number here. And then we're going to add that to 0 times 4. And that's -9 plus 0, so that would just be -9. Okay, and then final answer, so we can just put it right here, so when I scroll back up, was -2, 10, and then 3, -9. And that was the final answer we're looking for there. Okay, and to me, the math is not hard because it's just multiplying and then addition or subtraction. So the math is not complicated. The only thing that's complicated is just keeping up that it's got to be, the rows of the first one. It's the side-to-side movement here times the up and down movement here. And you've got to just basically kind of do one at a time when you go through these. Sometimes the 2x2 matrices are I don't want to say that they're hard, but sometimes because they're so square that sometimes it's easy to get lost. Let me give you something that's got a different size so you can just see. Sometimes the ones with different sizes to me are a little bit easier to see just because of how they're set up and what goes through these. So. All right, so let's say matrix X is 10, 1, 0, 9, and 6, 0, 0, 5. And for Y, let's say it's 6, 3, 2, 1. Okay, so before we do anything, kind of go ahead and get used to the size of it here. For matrix X, there's 2 rows. And then columns, you've got 1, 2, 3, 4 columns of answers. So it's a 2x4 matrix. Okay, and for Y, it's stacked up. So there's one column here, so it's 1, 2, 3, 4 rows of numbers, and there's only one column that's there. So if we do X times Y, which is what we're looking at here, that one would be okay because the 2 numbers on the inside would be the same. So x times y would be a 2 by 1 matrix when we get finished with it. Okay, if it's 2 by 1, again, it means we've got 2 rows. So it means it's two numbers up and down, and then there's only one number side to side, if you want to think about it that way. So this tells you how many the rows are, how much are up and down. So we got 2 numbers that go up and down, only one number that side to side that we're actually going to move over there. Okay, so here we go. So if we're going to find x, y, it's the first row of x times the first column of y, which again, there's only one column, so it has to be that way. So first row of x, that's the 10, 1, 0, 9. We're going to multiply that by 6, 3, 2, 1. All right, and again, just one number at a time, multiply them together. So it's 10 times 6. If you don't write the numbers down, that's fine. Because these numbers, we can do it in our head. 10 times 6 is 60. We've got to do 1 times 3, which is 3. 0 times 2, which will be 0. And then the last one, 9 times 1 is 9. So it's 63 plus 9. That'll make it 72. Okay, and since there's only one column, once we multiplied this row by this column, there's nothing else for this row to multiply. So now we're going to jump down to the second row. So now we're going to do the second row of x times the first column of y. And again, because there is the only one column, so that does make it a little bit easier because there's only one column to multiply by. So 6005 times 6321. All right, so we got 6 times 6 for 36. The zeros make it a little easier because 0 times 3 is 0. 0 times 2, also 0. And then for the last one, 5 times 1 would be 5. So that's 36 plus 5, so that would get us a 41. Okay, and then scrolling back up here, that would make that matrix 7241. Okay, I'll bring it back down here so we can see a little bit better. So 72 was that first number we found from up here. 41 was the second number. So that would be the final answer we're looking for at 7241. Okay, so that was finding x times y. And again, a lot of times on these, they may reverse it back around, and they may ask you, can you find yx? Well, from back up here, we said y was a 4 by 1 matrix, and x was a 2 by 4 matrix. Those numbers don't match up, so can you find it? No, it's not possible. Okay, and then let me give you another one or two examples, just again, just different size matrices that we're going to work on and multiply and see what we can get. And then just, that way, again, just once we see a couple of different ones, hopefully it'll start to kind of click. Again, the main thing is just focus on that it's always rows times columns when we go through these. All right, so for this one, let's say that, let's just do some different numbers. Let's say h is -1, -2, 5. Or -1, -2, -5. And let's say that j is 2, 4, 0, 5, and -3, -1. All right, again, first thing probably you want to do on these is size for this one. There's only one row, but there's 3 numbers. If you go up and down, then there's 3 different numbers here. So this would be a 1x3 matrix. All right, for J, there's 1, 2, 3 rows going up and down. And then going this way, there's 2 columns. So it would be a 3x2 matrix. Okay, so if we're asked to find H times J, that one would work out because we've got the 3's in the middle that would be the same. So the answer size for H times J, when multiplied together, it's going to be a 1x2 matrix. Okay, now again, just on a side note over here, they'll be separate from it. Could we find J times H? Well, if you reverse it, put a 3x2 for the J, 1x3 for the H. Those 2 numbers don't match up, so that one wouldn't be possible. Okay. Again, I know there's at least a couple of homework questions. That's all they ask you to do is, can you find it? Yes or no. And that's all it is. It's just a yes, you can, or no, you can't, just depending on the size of what's there. But for this one, we're going to go ahead and run through HJ so we can see what that answer would be here. All right. And again, when we're going through this one, it's always the rows of the first times the columns of the second. So we need the rows of H, which in this case would be -1, -2, -5. And we got to multiply that by the first column in J. So first row times first column. So 2, 0, -3. All right, and again, once you get the setup, and that was the part that always kind of threw me off when I was doing this for the first time. The setup just would throw me off. Once I got past that, I was okay because like, okay, now I'm just multiplying. Now it's just -1 times 2. Well, that's -2. It's -2 times 0, which is 0, and then it's -5 times -3, which was a +15. Okay, so -2 plus 0, -2, 15, and -2. It's going to bring that out to be 13. Okay, again, if you're keeping up with how this thing is for the answers here, if we were, because I think a lot of times on Math Excel to show it this way, a 1x2 matrix means you only have one row, but there's 2 numbers that will be in that row. So basically, it looks something like that. So just one row with 2 numbers in that row. Okay, so that 13 would be the first number that would be in that matrix. That 13 would be in there. And since there's only the one row here in the H, and we multiplied it by this one, well, the only thing left then to do is take the row that's here and multiply it by the second column. So then we're up to first row, and then the second column. All right, we're out of room there, so let me slide it down so we can see it. So -1, -2, -5. And now we're going to the second column, so that's at 4, 5, -1. Okay, so then it's -1 times 4, which would be -4. -2 times -5, which would be -10. and then negative 5 times negative 1, which would be a positive 5. So negative 14 plus 5 would make that out to be negative 9. Okay, so final answer then would put that at 13, negative 9, so it would look something like that. Okay, so for multiplying matrices, that's it. That's all you have to do is keep up with. And again, the hardest part to me was just keeping up that it's always the rows of the first one and the columns of the second one. And then once you've got those two things written out, well, that's real easy. It's the first times the first, it's the second times the second, and it's the last times the last. And then just kind of going through and adding up to all those, or subtracting them, just depending on the way the signs work out, just going through the numbers on that one to kind of figure out what you've got to do. So, all right, well, that's it. That's all multiplying matrices is. So.